So basically, you must know moment of inertia for most of the rigid bodies. Solid cone we didn't discuss. Just I took one problem. Then I'll discuss one numerical related to this also. This is the axis about which is asking us to determine it. How to calculate this? So what is the best thing we can assume? This one, I'll assume a strip. Let this be the y, radius of this be y, let it be at x, and let this be distance dx. This is r. First, we'll find out moment of inertia of this. What is that strip? Can you give any name for that strip? It's a thin disc, no? We are supposed to calculate about y dash. So there's a thin disc, that one. What is the mass? Overall, it's a solid cone. He has given density. What is the volume of cone? Density equal to mass by pi r square h by 3, or 3m by pi r square h. The density of the cone. So what is the mass of this small elemental thin disk? dm should be equal to rho into pi y square into dx. No, it should be. Thickness is how much? Dx. Dx is very small. Y is the radius. So rho pi y square. So the value of rho, we know it. That later we are going to substitute here. Now then, what is the relation between y and x? So you take help of tan theta. Tan theta will be y by x equal to r by h. So where all r is there, so that I'm going to replace here. Now altogether y we know r x by h. I'll differentiate this dy equal to r by h into dx. So in place of dx, now I can replace this one. In place of dx, I can replace this one. No, first, what is the in place of dm, I can write it. So now what is our next part of calculation? dm is equal to dm, after substituting this, rho pi y square r h h by r into dy. This is the value of dm. Now, okay, fine. But how to get the moment of inertia? You didn't ask to get all these things, no? That is asking moment of inertia. So first, what happened? I'll find out the moment of inertia of this thin disk about axis y dash using Parallax's theorem. Then I'll integrate. I'll get the total moment of inertia. So what should be the di y dash should be equal to first about its parallel axis. So dm y square by 4. Will I agree? About any diameter mr square by 4. So what is the radius of that? Y square, mass is dm, and this is 4. Plus, at what distance that thin disk we assumed? At a distance x square. So now you can replace that x using this formula. Integrate this, you'll get the required answer. So are you able to understand this one? So how to calculate the dm? There's a method. Then what should be the limit? 0 to capital H, because this is x equal to 0. This is x equal to h. Just mathematics, nothing to do that one. Sir, so this what should be the limit now? So here only I'll put the limit total, and this should be 0 to h. So instead of solid cone, he may ask you square pyramid. Then you are going to assume a thin square plate. That the same ideas is what you are going to implement here. Such a cone, do calculation, answer will be 7. Answer will be 7. You can, is asking the value of the eta there. There is a 7 will come. And now about x-axis, what to do? About x-axis. Again, the same formula. You already know dm. So about x dash, if I ask you to determine, so what you are going to do here now? X dash, about horizontal axis passing through the center of the cone. Then we know what is the moment of inertia of this. Di is equal to, no need of parallax theorem, no, directly there. So Di, here only will finish off this so that it be easy for you. This should be equal to how much? Dm y square by 2. Now what should be the limit again? 0 to h. Are you able to understand? I am just trying to wind up the both ideas in one problem. This is about axis of cone. You should be very good enough in this math-based problem. No concept, nothing is there. Just you have to apply the mathematics in a systematic way. And then such a cone, say how the application questions will be there. The cone, they'll take it and they will release. Find the linear velocity of a point like a O when the axis of cone becomes vertical. So how much of linear velocity it will have? So it will have angular velocity omega, then h. So then what is the equation you can write it? There's a solid cone of height h of mass m. Tell me like I want the velocity of point O. So what is the method here? Decrease in gravitational potential. Where the center of mass of solid cone will come? H by 4 from the bottom. So how much of center of mass will descend? 3h by 4. So decrease in potential energy mg 3h by 4 should be equal to, call this as point P. High P omega square by 2. Just now what I discussed the problem, no, that IP is going to help you like. So in exams, what will happen? Students will think some new concept is there. So what is the basic requirement? You must know how to get the moment of inertia of the standard rigid bodies about any axis. Until this, if you don't know that, I think not possible, no? So what we have got it, no? So this has to be now taken help in this to solve such problems. But this, so best thing is like a rod. So from rod, what mean you should migrate to the different conditions here. Okay, let me proceed with the next idea. There is a square plate. I'll make a hole here. Now what is this? This is a hole. This is a square plate of side length L and having a density sigma. Then what is the moment of inertia about z axis passing through origin? IOZ has to be determined here. This is a hole. Then what should be the approach? Again, in the center of mass, we brought it. No, first we'll calculate the moment of inertia of square plate, then of that of the circular disc, then we'll subtract. We'll get the required answer. So what is the total moment of inertia IOZ? This IOZ should be equal to moment of inertia IOZ IZ about, so IOZ only, let me write, of the plate plus moment of inertia about axis passing through and perpendicular to plane of that of the hole. What is the basic assumption what we have to do? So this is like plate, this is point 2, will have a mass m, side length L, positive density. What about this? This is a hole of radius r, negative density, mass will be m2. And it will be at a certain distance. It will be say like about this point O. Not O is not center of the hole. O is this one. Z axis passing or about origin. What is the axis? Axis passing through origin and perpendicular to plane. High OZ is what I wrote here. Find MI of plate with hole about Z axis. Okay, fine. This is a question. How to calculate the mass M1? Mass M1 is sigma into L square. What about mass M2? Sigma into pi r square. It should be negative, no? Why negative? Because when you keep that negative density material, positive density, negative density will cancel out and we'll get a plate with a hole. Now what should be the formula now? How we have to write this? That of the plate, it should be equal to m1 L square by 6 plus m1 into at what distance the center of mass will be at a distance L by 2 whole square. From where this is brought? From where this is brought? Parallax theorem. Moment of inertia about axis passing through O perpendicular to plane for this plate, this one. Moment of inertia about axis passing through center of mass m1 L square by 6 plus m1 into L by 2 whole square. Okay, now come for the plate one. Now for the hole, what is the parallax theorem? First, about axis passing through its center of the hole. How much it should be? m2 r square by 2. It's a disk, no? It will become plus m2 into. What can be the distance? At what distance the center of mass of the hole from the origin? 2L minus R. Solve this, you'll get the required answer. So, but what you have to do, you have to substitute m2 with negative sign. That you should not forget here. There you'll go wrong. So that m2 should be substituted with negative sign. I'll show this. This is something very important. So for your convenient, I'll write plus, and that will be negative sign. Please do notice the signs. So in place of all what you have to bring this idea. So this all now I can bring in sphere, I can bring in cone here also what level. I can bring some a spherical cavity here. Then as usual moment of inertia of cone, in that you should subtract moment of inertia of this spherical cavity about this axis. And this is a very popular, you feel this very easy, but in exams in one of the year, 7 cavity problems. Cavity problems already you've seen center of mass, that one. Almost in 7 chapters in physics it will come, and there was 7 different chapter questions were there in one question paper in 1 year. So even if a student learns in any one chapter, I think you can manage in all other chapters. That's advantage. So don't neglect anything. So don't bother easy, tough. Is it a good concept is there or not? If you're able to solve, not easy. Good concept is involved or not, that you have to focus here. Okay, this is about the this one. So we'll focus on other set of numericals. Okay, no.